So today we're comparing rational versus irrational numbers. Let's talk about rational first. Rational numbers, by definition, can be fractions, like 1/2, or such as a fraction like 1/3. But both of these fractions can also be converted to decimals. For example, if you take 1 and divide it by 2, you end up with 0.5. And this is called a terminating decimal because when you do the long division, it actually just stops. It's 0.5. Now 1/3 is a little bit different, but it's also rational. So this would be an example of it terminates. 1/3 though, if you type that in or you do your long division, you're going to have 0.33333, and you probably figured out by now that it's going to go on forever. So when you see these dots, that just means that the number goes on. It just keeps going on. Now this is called a repeating decimal because there's something that repeats. In this case, it's the 3. It's going to keep going. And most of the time when you see that, you're going to go ahead and rewrite it, but then you'll put bar notation over that which repeats. So again, you can have a fraction or a decimal that terminates, or you can have a fraction and something that repeats. Now the last type of rational right here is you can have square roots, but the number underneath actually has to be a perfect square, like 9 or 25 or 100, because we all know that the square root of 9 is just 3. Okay, cool. Now irrational is everything the opposite of what we have here. So for example, we can't write it as fractions. Now you're going to see some decimals here, but the type of decimals will look kind of like this. You'd have 0 point, and then it's going to go on forever, so you can really just almost give me whichever numbers you want. So I'll go 2, 3, 8, 0, 0, 3, 4, 2, and then typically it'll have a dot, 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 which means it goes forever. All right? But here's the deal. Again, rational means it terminates. This obviously doesn't terminate, and it's rational if it's a repeating. But notice this doesn't terminate and it doesn't repeat. So that's a really good example of irrational. Now the other type of irrational you'll have, it'll be kind of like this. It'll be a square root, but instead of having like a perfect square underneath here, you're going to have a non-perfect square. So for example, that would be like the square root of 10. Which we know is a little bit bigger than 3. If you type that into the calculator, it's going to give you something like 3 decimal, and then it's going to have a slew of numbers here, and I'm just going to make this up. 1, 2, 0, 8, 9, dot, dot, dot. It's going to go on forever, and there's going to be no pattern. So let's go ahead and use the statements from Delta Math to kind of organize our thoughts. And then we'll get into some examples from Delta Math. So it's a decimal that does not repeat or terminate. That's like this right here. That's irrational. If the decimal terminates, that's like 0.5. That is rational. If it's a decimal that repeats, that's like 1/3 or 0.3 repeating. So that's rational. If it is the square root of a perfect square, that's like the square root of 9. That's rational. And then lastly, if it's the square root of a non-perfect square. All right, cool. Let's go into Delta Math. Okay, so we've got our notes out here to the side. Let's look at these numbers. Determine if the square root of 16 is rational or irrational. Well, let's see. So let's take a look over here. If it's a perfect square, it's considered rational. So the square root of a perfect square. Whereas if it's the square root of a non-perfect square, it's irrational. So that's a perfect square. So I'm going to go ahead and say it's rational, and that it is the square root of a perfect square. And we're good to go. So I just want to note that the work that you're going to provide, you're simply going to copy this sentence down here on your worksheet. So you're simply going to write the number, square root 16 is rational because the square root is a perfect square. Just write that down. Now notice that I did the square root of 16 is equal to 4. And that means that we have an example for this one. So let's see if I can find an example for each set. All right, our next one. Determine if 0.68 is rational, irrational, and give a reason for that. So here's the decimal. The first thing I'd like to point out is it doesn't have the dot, 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 which means it goes on forever. And if it doesn't go on forever, by definition, it has to terminate. So over here, notice that if it's a decimal that terminates, it's rational. So I'm going to go ahead and say that this is rational, and it is a decimal that terminates. And let's go ahead and we'll just copy that one. right here. And I'm just going to go ahead and paste this number in the appropriate spot. So there is 0.68, and then we'll draw a line through this one. So we have something that terminates. Okay, determine if, again, look at the decimal, see the dot, dot, dot. So either, if this is going to be rational, it's going to repeat. It's going to have something that repeats over and over and over. Or if it has the dot, 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 and it doesn't repeat, it's irrational. So let's take a look. So we have 39, and then we have 399. Wait a second, so there's 39, but then we would expect if it was going to be the 39 repeating, it'd be 3939, but it's not. Then it's 399, and then it's 3,999. So although this has a pattern where it keeps adding a 9, it doesn't actually repeat. If it repeated, it would be 39, 39, or yeah. So this is definitely one that's a little bit tricky, but it is definitely irrational, and we would say it is a decimal that does not repeat or terminate. And let's go ahead and paste that on our sheet. Okay, it's not going to fit perfectly, so let me go ahead and just move this underneath. So there's the example for that. So this one is a decimal that does not repeat and doesn't terminate. And let me cross that one up. Now we have an example of irrational number for a decimal. Right, let's try another one. Determine if the square root of 23 is rational or irrational and give a reason. Well, okay, so here's the deal. Process of elimination probably means that this is going to be a non-perfect square. 23 is above square root 16 but below 25. Again, 16 and 25 are both perfect squares. So this one is irrational because it is a non-perfect square. Square root of a non-perfect square. And I like how right here how we actually have the decimal equivalent. And so notice that it's 795,831,5233. It has the dot, 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 which means it goes on forever, and obviously there's not a pattern. All right, so let's look for the last example. We're going to look for a decimal that does repeat. Okay, I kind of hinted that we're already going to get this one. This is going to be an example right here of a decimal that does repeat. So note, I want to just point out the repeat. It's 7653, 7653, 7653. So this is actually the part that repeats, 7653. So because it repeats, I'm going to say that it's rational and that it repeats and put that in there. And then let's go ahead and just capture that and place it on our sheet. And there's an example here. I'll just sneak it over here. Now I do want to let you know you could have done 0.7653 and then you could have written the bar notation over this part and then stopped right there. But whatever. Now you've got an example for a decimal that terminates, 0.68, a decimal that repeats, decimal 7653, square root of a perfect square, which would be square root 16. An irrational number is a number that goes on forever and it doesn't repeat, or the square root of a non-perfect square. So again, if that's not those perfect squares underneath there, it's irrational. And there you have it. Thanks for viewing.